So what if all the incredible energy we pour into mining cryptocurrency could actually be used for something else? Something huge. Like, what if it could help us build the quantum computers of the future? That's the wild idea we're going to break down right now. I know, it sounds a little like science fiction, doesn't it? But the core idea is pretty straightforward. What if all that raw computing power could be pointed at one of the biggest roadblocks holding quantum computing back? To really get how that works, we need to understand both the incredible promise and the very real problem. Okay, so let's start with the promise. Quantum computing isn't just about making faster computers. It's a completely different way of thinking about computation. We're talking about machines that could solve problems that are literally impossible for even the biggest supercomputers on Earth today. Think about discovering new medicines, designing revolutionary materials. It's a whole new ballgame. But, and this is a big but, there's a catch. Harnessing all that quantum power is unbelievably tricky. It's not just building the machine itself. It's getting the software, the actual quantum programs, ready to go. And that is a massive, massive challenge. A huge part of that challenge? It comes down to one very specific, very difficult ingredient in the whole recipe. This brings us to what's known in the field as the T-gate bottleneck. Yeah. If you think of a quantum program as this super complex recipe, most of the steps are, manageable. But this one step, it's like a rare, incredibly expensive, and fragile ingredient that you absolutely have to get right. And that ingredient is called the T-gate. It's a fundamental operation. You can't get around it for a lot of important algorithms. But performing a T-gate is just wildly expensive in terms of resources. Why? Because it's so incredibly sensitive to noise and errors. To make it work, you have to wrap it in these complex layers of error correction, which eats up a ton of the computer's precious, fragile resources. And this has some really serious knock-on effects. First off, it makes the programs incredibly slow. The amount of extra work you have to do for every single T-date just grinds the whole process down, making it take forever just to get a program ready, let alone actually run it. Second, it makes the whole system super fragile. Because T-gates are so touchy, you need all those layers of error correction I mentioned. This adds this huge layer of complexity, making the entire computation just delicate. It's way more likely to fail. And finally, you guessed it, all of this makes quantum computing expensive. And we're not just talking about money. We're talking about time, resources, computational power, you name it. The T-gate is, hands down, the biggest bottleneck holding everything back. So, how do you get around it? Well, this is where a more efficient recipe comes into the picture, all thanks to a brand new optimization tool. Okay, get this. The tool is called rmsynth, and its job is simple but absolutely brilliant. It takes a quantum program, looks at it, and then intelligently rewrites it to get the exact same result, but by using way, way fewer of those expensive T-gates. It basically finds a smarter, more efficient shortcut to the same destination. And the results are, well, they're staggering. This isn't just a tiny little improvement. rmsynth can slash the number of T-gates you need by anywhere from 6 to a whopping 75%. In the quantum world, that's not just an improvement. That's a potential game changer. I mean, a 75% reduction could turn a problem that takes a year to prep into one that takes just a few months. That is huge. Probably the best way to think about it is like this. Imagine a master chef figures out how to make a Michelin star meal, but without needing the rarest, most expensive, and most delicate ingredients. You get the same incredible result, just with a much simpler, cheaper, and more reliable recipe. And the crucial thing to remember here is that this is not some theoretical idea floating around in a lab. rmsynth is a real working tool that solves a practical problem quantum researchers are banging their heads against right now. It's a real solution to a major roadblock. Now, let's see how this idea gets even bigger. And this is where the story takes this really fascinating turn, connecting this quantum breakthrough to the world of cryptocurrency. So here's the crazy connection. That really hard computational work that rmsynth does to optimize quantum circuits, it's the exact same work that powers the mining for a cryptocurrency called the Qubitcoin network. So instead of their miners solving some random, useless puzzle, their mining task, they call it Planck, is literally performing this incredibly valuable quantum optimization. This just creates such a powerful contrast with traditional crypto mining, right? On one side, you have systems burning mountains of energy to solve abstract puzzles that have zero value outside of just securing the network. But on the other side, you have Qubitcoin channeling that same energy into solving a real problem that has clear, real-world value, making quantum computing more practical.
So what this does is it creates a whole new kind of economic model. The currency, QTC, basically becomes a direct payment for useful work being done. This means its demand is driven by actual utility, by researchers and companies who need to optimize their quantum programs, not just by speculative hype. It lets labs tap into this powerful optimization network without having to build their own expensive systems from scratch. So what does this all mean for the future? Well, it means we're actually laying the groundwork right now for that huge quantum promise we talked about at the beginning.
What the Qubitcoin network is really doing is turning a difficult, kind of theoretical, computational problem into a useful, tradable service that's available today. It's like a bridge connecting today's computers to the quantum computers of tomorrow, using the resources we have now to pave the way for what's next.
And the potential impact is just enormous. By making quantum computing more efficient, more accessible, this kind of work helps speed up progress towards those world-changing applications we all dream about. We're talking discovering new drugs, creating revolutionary new materials, building perfectly secure communication networks, and maybe, just maybe, solving some of humanity's biggest challenges. And all of this leaves us with one last, big, provocative thought. By tying all that computational effort directly to real-world value, this model presents a powerful new vision for what crypto could be. It really makes you wonder, is proof of useful work the future of digital currency?